So today, coding wise, we are going to be doing maybe 5-6 problems of Leetcode. I'm just going to be walking through like some of these are probably going to be problems I've done before. Maybe I haven't. We're going to go to the grind 75. Since I have a few upcoming like online assessments for jobs. So we're just gonna do that and go through like just do a little broad view of the questions by topic. So I know this website's really good, Tech Interview Handbook. It goes through all the different topics that are introduced in tech interviews. It just kind of gives you a good okay, so essential questions. To sum, best time to buy and sell stock, product of array except sub, and maximum sub array. Okay. I think everyone's done to sum already. Or actually, let's go through the Leetcode.io stuff just to see. Just the Leetcode 150. Let's do one medium problem from each topic. That should be good enough for now. Okay. Let's do contains duplicate and to sum, which we already have pulled up. Group anagrams. As well. Oh no, let's do valid anagram. And that's what we're gonna do in terms of array and hashing. For 2 pointers, let's do 3 sum again. I'm not even sure if I remember how to do this. Sliding window, let's do this, and then longest substring without repeating characters, 2 problems. Well, hopefully this is like enough to get us kind of in shape. Just for some simple. Okay, so to sum, we're given an array of integers and an integer target. Return the indices of 2 numbers such that they add up to the target. So our input is going to be an array. Right, 2, 7, 11, 15. Is it guaranteed that there is a solution? Okay, so guaranteed solution. That's good to know. So we know so as we go through the array, right, what we're going to do is I can think of kind of two approaches that we can take to this. One of them is the original hash, is a hash map approach. Well, the naive solution is just looping through everyone and checking if it's the target. And then returning the target. But that's going to be O of n squared. So we want to get that down. The second solution we can employ is a hash map solution where our keys will be our keys are going to be the value themselves, and then the values is going to be the difference, right? So that's simple. So as we loop through the array, so from some pseudocode, as we loop through the array, I'm thinking I'm just not thinking out loud, right? I'm writing all this down just for interviews. So for every element in the nums array, right? So if we see some, if our I is not in the hash map, right? So we haven't seen it yet. Then let's insert it. So this is a hash map of I, or the value, the key is going to be the target minus the minus I, right? So like, for example, we're gonna have 2, 7, or right, target 9. So we're gonna have 2, 7, and then we're gonna have 7, 2, right? Then we check if difference is in it, right? That means we have already seen that key, so then we just return the indices. Actually, let me rethink this solution. Okay, we need. Okay. I read this problem wrong. So we actually need the indices of the values. Okay, so scratch that. So that means for every num in nums, or length nums, the indices, right? So then we want to calculate the difference. Again, equals target minus nums I, right? Then we say if the difference is in the map, right? Because we've already seen it. Then we return I, and then hash map difference, and then our key is going to be the number, and then our value is going to be the index. And that should work out quite fine, I'm assuming. And num's length has to be 2. So one edge case, if length nums equals 2, right? We just return 0, 1, right? Because there's only 2 elements in it. And then it's guaranteed to reach the target, right? And then we're gonna have to declare a hash map like this. And then we're gonna say for I in lang nums, or in range lang nums, what's gonna happen is difference equals target minus nums of I, and then if the difference is in the hash map, right, then we just return hash map of difference and then I. If not, then we just add it. Hash map of nums I was I. There we go. Okay, contains duplicate. Given an array nums, return true if the value appears at least twice in the array, and return false if every element is distinct. Some edge cases. So if lang nums equals 1, right, then we know there's no duplicates, then it's just true. Or false. And for this problem, the initial one solution I can think of is, right, we just turn the array into a set and then check if they equal each other. And then in Python, that's like I think that's gonna O event. It's gonna be O event, like a slightly faster way. I mean, it's still gonna be O event, but we just loop through the array, try to add it to a hash set, and if it's already in it, then we return contains duplicate is true. Okay, so we'll do that. Hash set equals set, right? So then for num in nums, then what we're gonna do is if num in hash set, return true, right? Return false otherwise. I guess we don't even need this. Uh-oh. Let me see the other submissions I have for this problem. See if I beat that. What the heck? 1200 milliseconds. That's not good. What did I do here? Oh, yeah. Okay. So that contains duplicate. Okay, buy and sell stocks. Code. And then we can do longest substring without So we did valid anagram, we did twosome, we did not do valid anagram yet. Okay, so we'll do valid anagram. So valid anagram, given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or a phrase formed by rearranging the letters of different word or phrase, typically using all letters exactly once. Well, so one edge case I can immediately think of is if they're not equal length, then they're definitely not anagrams of each other, right? And then what we can do is we can, if they're anagrams and they're the same length, and then we can just check that we can use two hash maps, S map and T map, right? Where we can loop through both strings and then update counts for the number, for the key of the key of the characters. So the character counts. So for example, in the word anagram, the letter A appears 3 times, and then in the word nagram, it's the same thing. So we just do that. So for C in lang S, since they're guaranteed to be the same lang, then S map of S of C, right, equals S map dot get S of C, or 0 plus 1, which is, and then we do the same thing for T map, or T of C. And what we can do here, so we can just say return T map equals S map. Range, I guess. Linus. Hey, that's good. Okay, so we did these 3. We're gonna want to do a valid palindrome and threesome as well. Valid palindrome. And then threesome. Threesome. Just to get us just in the mood. Oops. Okay, valid palindrome. A phrase is a palindrome if after converting all the uppercase letters into lowercase and letters and removing all the alphanumeric characters, it reads the same forward and backward. So one way you could do this is just reverse the string, or strip the string of everything and then reverse the string and check if it's equal to each other. So another way we can do this is we can start a pointer at the end and start a pointer at the top, or top end, and then if we see a character that's not like an alphanumeric character, then we will decrement or increment And then if they do not, okay, and then if it's not equal to each other, then it's definitely not a palindrome. And then we just return true at the end, I think. Just return true at the end, right? So we're gonna say left pointer, right pointer is gonna be 0, and then leg of s minus 1. So while left is less than right, because we definitely want that to be the case. Okay, so while left is less than right, if right not there's a function called isAllNum. Let me just check if this is right. Okay, so it's just called isAllNum. If not, s is allNum, left plus equals 1. If not, s of r, that is allNum, right minus equal 1. Otherwise, I think this is going to be an elif. Else, right? If s of r, oh, and we want to make these all lowercase. Python string dot lower, okay. If s of r dot lower does not equal s of l dot lower, right, return false, and then otherwise we just increment, decrement, right. And I think this problem is done. Uh-oh. What happened? Analyze complexity. It is indeed O then, because we're only going through it once. Let me see what happened here. This is the same solution. Oh, this is the exact same solution I submitted last time. Cool. Okay, threesome. So given an integer array of nums, return all triplets. Nums I, nums j, nums k. I does not equal j, I does not equal k, and j does not equal k. Nums I, nums j, nums k equals 0. Notice the solution must not contain duplicate triplets. Okay. So intuitively, how this solution works is kind of like a binary search. And what we're going to have to do here is for every index in the array, right? We're going to declare one of them, say, the middle, right? Or the current target that we're looking for, that we want to see if we have any triplets. And then we're going to start a pointer right after that one, after that index, and then we're going to start a pointer at the end. And then we're going to decrement and increment until we get like a 0 value. And if there is a 0 value, then we will add that as a triplet. And afterwards, we'll increment and decrement the left and right pointer until there are no more duplicate values, and see if there are any more triplets that can be derived from that current target. So the first thing we have to remember to do here, right, to make this problem really easy is just sort the array, right? So our result is going to be an array. And then for I, val, and then enumerate nums, right? So if, okay, right. Since we already sorted it, that means everything else is going to be bigger on the right. So if our value is greater than 0, then just break. Like if it's a positive value and everything else is greater than that, then there's no way there will be a negative value after that to decrease it to 0. So, and then the other edge case we have to account for here is if I is greater than 0 and val, the current val equals nums of I minus 1, because we don't want any duplicate values, right? So now we set target equals to I, or no, left equals I plus 1, R equals nums if, okay, so we're going to designate a cur sum equals nums of L plus nums of R plus nums of I, or which is our current target, right? So if this sum, cur sum, greater than 0, that means we're too big, we should decrement the right. L if the cur sum is less than 0, that means we're too small, so we want to increment the left. Else equals 0. Right, we're going to want to add the pair, the triplet, which is going to be res.append LRI. Is that right? They want the indices? Oh no, they actually want the value this time. Right. So they want the triplet. And we're gonna increment left, decrement right, while, okay, this one's important. So we want to see if we can derive any more triplets out of this specific value and 2 more pairs. So while L is less than R and nums of L does not equal nums of L minus 1, right? L plus equals 1. While L minus R and nums of R does not equal nums of R plus 1, then we increment the R. We just return the result. Valid syntax. Uh-oh. Wrong answer. Oops. Alright, where did we go wrong? Okay. So this scenario is going to be -1, 0, 1, 2. 2, negative 1, negative 4. So the sorted array is going to be negative 1, negative 1, 0, 1, or negative 4, negative 1, negative 1, 0, 1, 2. Zero, 1, 2, right? So maybe it's this, but I don't think this would be the case. We might get an index out of bounds error. Okay, yeah, that's probably why that's not the case. Okay, right. So for I-val and enumerate nums, so we're missing negative 1, 0, 1. That'll happen when negative 1 is the value of interest. Right, so we have 1 here. So initially the current sum is 0. Negative 1, negative 1, 2. Oh. This is... No, I found my error. Okay. Still didn't fix it. Okay, anyways, let's keep going. So we already append negative 1 to negative 1, right? So that's in the result. And our target has not changed yet. Right. So that means while, okay, L plus equals 1. So L is going to be negative 1 again. Oh, okay. I see. So right is going to stay the same. Right is not decrement. Actually, right will decrement 1. Right will decrement here. Right will be at 1. So then left will increment 1 to negative 1 again. And then while L is less than R and nums of L does not equal. So L will be at 0, R will be at 1, right? And then L is still less than R. I'm confused as to which. How come? Where did I go wrong? Uh-oh. Well, it looks like the same code. Oh, okay. I see where we're going. We're decrementing when it's not equal. We should be decrementing and incrementing when it's equal. I see. Dummy me. Okay. Length of longest substring without repeating characters. I think this is gonna be the last one I do for today. Okay, so given an S string, find the length of the longest substring without repeating characters. So if we have S equals ABC, ABC, BB, then our longest substring is going to be 3. We can treat this as a 2-pointer problem, actually sliding window problem, probably. Right. Okay, so if not S, return 0. Left equals 0. Okay, well, it's going to be initialized as 0. ABC, ABC, BB. Right, then in that case, enters ABC with length 3. So how we want to initialize this? So I'm going to use a hash map. Oh no, actually a set. Right, a set for this. So we're gonna have left. So we're gonna add right to the set. So for example, in our ABC, ABC, BB, we're gonna add A to the set. A. Right, and if it's not in the set, then we add it. So we're gonna keep adding it. A, B, C. Right, and then we're gonna calculate the length until we get to something like another A without repeating characters. So right, and then what we're going to want to do is we're going to want to remove the character at left and then increment the left again. I think that's how that works. Right. So while left is less than right, and overall it's going to just go through the array one more time. So if not, or no, let's first handle the situation if it's if S of L, or no, if it's, oh no, if S of R is in hash set already, then what we want to do is we want to do hash set dot remove S of L else. And when do we come up with res? I'm not actually sure if this is how it works or not. It might be wrong. Uh-oh. Still 0. Nice. Oh, because we're not incrementing. Lol. This is funny. What a goofy time. Still wrong answer. Nice. Let's go through this and just see what's going on here. So while we have A, B, C, B, B. So while L is less than R, L is going to be 0, R is going to be 0. So if S of R is in hash set, S of R is not in hash set. If S of R is in hash set, nope. Right. Oh. So goofy. Still 0. Very nice. Okay. So hash set dot R. So now R equals 1. So smart. Huh. Okay, I need to figure out when we actually need to compute this whole result. We either compute it at every single iteration, or we compute. Okay, I guess it's every single iteration. Okay. Nice. There we go. Simple solution. What were the solutions that I've had put separate? Okay, so if it's not in the set, then we add it. House. Oh, okay. Basically the same solution. Cool. There we go. Anyways, thank you for coding with me today. This is, I guess, a more traditional style Leetcode type of thing. So, cool. Thank you guys for watching. I'll be here tomorrow.